It doesn't care if we're ready. For every aurora and newborn star, there's a hazard waiting in the dark. Tonight, we're taking a long look at the wonders and the threats hiding in the cosmos. This is a backwards countdown from 25 to 1. The most astonishing space facts that will both terrify and amaze you. Listener discretion and a healthy dose of curiosity advised. 25. The speed of light. Light races at 299,792,458 meters per second, about 300,000 kilometers per second, or 186,282 miles per second. At even a fraction of that speed, lone hydrogen atoms become radiation bullets, slamming into a ship with particle accelerator fury. The closer you go to light speed, the more the universe fights back. Time slows for you, distances contract, and your electronics face a constant storm of high-energy hits. 24. The Moon. Our Moon is slipping away by about 3.8 centimeters a year. That slow drift robs Earth of rotational speed, days lengthen by milliseconds per century. Deep time twist. Hundreds of millions of years ago, a day was closer to 21 hours. Given enough eons, Earth and Moon could tidally lock one face of Earth, always staring at one face of the Moon, while global tides weaken into a gentler heartbeat. 23. Black holes. Squeeze a sun's mass into a city-sized sphere and gravity wins everything. Black holes trap light, stretch time, and create tides strong enough to spaghettify matter. After collisions, gravitational recoil can kick a black hole at thousands of kilometers per second, ejecting it from its home galaxy. They don't just bend reality, they can leave. 22 gamma-ray bursts. The cosmos's flashbulbs, GRBs, can outshine galaxies in seconds. If a nearby burst's beam ever lined up with Earth, it could strip away ozone and drench the surface in radiation. Long bursts likely come from collapsing titans, short bursts from merging neutron stars. They're brief, beamed, and brutally bright, thankfully rare in our neighborhood. 21 Microgravity. Floating looks fun until your body rewrites itself. In microgravity, fluids surge toward your head, your vestibular system gets confused, bones can lose 1–2% density per month, and muscles waste without constant training. Astronauts fight back with hours of daily exercise just to return home close to normal. 20 Cold welding. No air, no oxide layer. In ultra-clean vacuum, similar metals can fuse on contact, 2 parts touch and become one. Engineers counter with coatings and smart design, but early satellites learned that in space, friction and stiction aren't just nuisances, they can lock mechanisms at the worst moment. 19 Alien life. With billions of sun-like stars and worlds in habitable zones, life elsewhere feels likely. Yet we've heard nothing conclusive. That's the Fermi paradox in one breath. High probability, zero proof. Maybe life is common, but intelligent life is rare. Maybe civilizations don't shout. Maybe the galaxy is busy and selective. 18 rogue planets. Not every world keeps its star. Some are kicked out during planetary chaos and drift forever in interstellar night. Surface temperatures plummet, but internal heat and pressure could sustain subsurface oceans dark, sealed habitats warm from within. Life without a sunrise isn't impossible, it's just strange. 17 travel times. Apollo needed about 3 days to reach the moon. Mars, with today's tech, takes 7 to 9 months. Pluto took New Horizons about 9.5 years. Outside our solar system, even light needs 4.37 years to reach Alpha Centauri. At light speed, the Milky Way's center is still to 26,000 years away. 16. Extreme temperatures. A supernova's shock front can soar to tens of millions of degrees, while the cosmic microwave background chills at 2.725. Kelvin -270.425 degrees Celsius, a whisper above absolute zero. In space, you don't get room temperature, you get furnace or freezer, often within the same scene. 15. The darkness. Darkness here isn't lights out, it's a shoreless ocean, billions of light years of unknown, your ancient fear of the dark. In space, it's not superstition, it's survival. The things you can't see outnumber the things you can by design. 14. Magnetars. Neutron stars with magnetic fields 1 trillion times stronger than Earth's. Get close enough and those fields can distort atoms. A single teaspoon of magnetar matter would weigh billions of tons on Earth. In 2004, a magnetar flare rattled Earth's ionosphere from 50,000 light-years away. That's power with reach. 13. Musculoskeletal atrophy. Gravity is your silent trainer. Remove it and your body economizes fast. Without strict workouts, astronauts lose strength, endurance, and bone. Some need months to rebuild on Earth. Space doesn't just test machines, it tests meat and bone. 12. Venus. Named for love, built like hell. Surface temperature around 465 degrees Celsius, pressure to 92 times Earth's, and clouds laced with sulfuric acid. Probes that land there don't last long. They're crushed, cooked, and corroded sometimes in under an hour. 11. Dark matter and dark energy. Everything we see, stars, gas, you, me, is about 5% of reality. Roughly 27% is dark matter, invisible mass we trace by gravity. Around 68% is dark energy, a pressure driving the universe to expand faster and faster. We map their fingerprint precisely and still don't know what they are. 10. Background radiation. Between planets, high-energy particles never stop. Deep space missions can rack up 0.5 to 1 millisievert per day, orders of magnitude above Earth's background. Shielding, smart trajectories, and storm shelters aren't luxuries, they're lifelines. 9. The expanding sun. As the sun fuses hydrogen into helium, it brightens. In the far future, Earth's oceans evaporate and climates fail. Around 5 billion years from now, the sun swells into a red giant, swallowing or scorching the inner planets. Our star gives life and a deadline. 8. Hypernovae. When the biggest stars die, they don't just explode, they detonate. Hypernovae can forge black holes and launch the most powerful gamma-ray bursts. They're so luminous, we see them across millions of light-years, cosmic lighthouses announcing endings. 7. Electromagnetic sounds. Sound waves can't cross vacuum, but plasma waves and electromagnetic oscillations do. Translate them to audio and planets, rings, and magnetic fields sing. The tracks are eerie, like wind through a cathedral built of charged particles and field lines. 6. No margin for error. In space, tiny issues scale fast. A pin-sized leak, a valve stuck half open, a micrometeoroid the size of sand. Fire behaves differently, CO2 can creep up silently, and ice on a seal can undo a mission. Redundancy saves lives until the one thing you didn't plan for shows up. 5. Time dilation. At high speed, time slows for you relative to people at rest. We correct for relativity in GPS satellites every day, about 38 microseconds of adjustment per satellite per day, or navigation breaks. Fast particles in labs live longer than they should because, from their perspective, the universe is moving and the clock is kind. 4. Hypervelocity stars. Get too close to a supermassive black hole and gravity can slingshot you out. Some stars race through the galaxy at 1-2 million miles per hour, about 1,600 on 3,200 kilometers per second, fast enough to escape the Milky Way entirely stellar bullets fired by gravity. 3. Solar flares. Our star is usually calm, sometimes furious. Big flares and coronal mass ejections can scramble GPS and radio, degrade satellites, and induce currents that trip power grids. The 1859 Carrington event lit auroras near the tropics and fried telegraph lines, a 19th century warning about 21st century risks. 2. Depressurization. Cross the Armstrong limit without a suit and water in your tissues starts to boil at body temperature. You don't explode, but you lose consciousness in 10-15 seconds, and ebullition and hypoxia follow. Spacesuits aren't costumes, they're pressure vessels between you and vacuum. 1. How the universe ends. Big crunch? Big rip? Right now, evidence favors the big freeze. Dark energy keeps accelerating expansion until galaxies thin out, stars die, black holes evaporate, and even atoms may decay. The cosmos fades into a cold, quiet darkness, not with a bang, but with a long dimming. Space is beautiful. Space is lethal. And somehow, it's home to minds that can understand both. If this journey lit up your curiosity, subscribe, share the one fact that rattled you most in the comments, and tell me what corner of the universe we should explore next. Until then, keep looking up, keep asking big questions, and remember, the night sky is a map and we've only read the first pages.